Hello, everybody. Welcome to the stream. It's your host with the most. It's the one and only. It's the Joe. It's the one you've always been waiting for. Hello, and welcome to the stream. All right, there, boys and girls, ladies and gentlemen of all ages. We're gonna have some fun tonight. What did I say today was? Today is Lab Day. The day on which we shall lab it up. And lab it up. And we shall lab it up some more. Alright, I hope you guys, if you're interested, downloaded Cisco Packet Tracer. Or have Cisco Packet Tracer or something else. GNS3, CML, ESXi, VirtualBox, something we can lab in today. I got a couple treats for us today. Well, I got a couple things I want to do today. Like I said, I had that, well, I want to start this off, though. I want to start today off again by giving another big shout out to my big sis. I tell you what, everybody, I don't know where I would be if it wasn't for my big sister. All right? So, here's to you, my big sister. I love you so much. If it wasn't for you, I wouldn't be here. Hold on. All right. That's the truth, everybody. So, all right. So, big day today, guys. I got some really good news and some really good news. I hopefully should have a job here soon. Today was like a big special day for me. Not only did I get one job offer today, I got another job offer today. So I'm really pumped. I'm super pumped. Doesn't mean the stream's gonna stop. The stream's gonna continue on. We're still going after it, all right? We're gonna be CCNA certified, all right? Because my dream is still to become a network engineer inside of the job that I hopefully will be getting here soon. So today was a really awesome day, guys. But I just want to say Merry Christmas to all you guys. And I hope and pray that all you guys' hopes and dreams come true on Christmas. This is always a very special time of year. Miracles do happen. All right. So, yeah. Breaking up. Yeah. So, kind of like not kind of, what I said yesterday was today I had a class going over DHCP, DNS, and stuff like that. I got I was able to get a good bit through the class. I had some issues though getting my lab environment actually set up beforehand, because my dumb cookus, I was I don't know why. I totally like brain farted on extracting a file, and I wasn't able to boot up pfSense on my ESXi server. I was having all kinds of issues, and because what I was trying to create was because off ESXi you can't just, it doesn't have a way, doesn't have a built-in way to build a NAT bridge for your VMs to be hosted off, like VirtualBox and VMware. You have the option. It's a simple click drop down option. You can bridge, or you can use a bridge adapter. You can use the NAT adapter. And if you have it and if you don't understand what that means, and I'll explain it to you, because I didn't know what that stuff meant either beforehand. Before I started studying for all this. So a bridge adapter, if you use a bridge adapter for your, like, say if you're in VirtualBox and you were to set I think by default in VirtualBox, everything's attached to the bridge adapter. So a bridge adapter will attach it right to your network. So you'll boot up a VM, and that VM will have an IP address similar to your PC, similar to your laptop, whatever you're using, because it's a bridge. It's a bridge right to your actual network. So you could probably, you should be able to ping devices within your own local network, and they'll all be on the same, subnet broadcast domain. Because, and so let me explain that. So NAT, though, when you attach it to like a NAT, when you attach it to like the NAT bridge, the NAT adapter, the NAT bridge adapter, what that's doing is inside. So inside, you'll see, like when you download VirtualBox or VMware, like you'll see it add, one or two additional network adapters to your actual host PC, and what that's doing is it's building in that bridge. It's building in that NAT bridge. That way, when you select NAT, it's pretty much it's bridging it. It's taking your network and then coming off of that. All right, and it's adding that NAT adapter, that network address translation adapter. So you're not directly on your actual network, okay? You can go out to the internet, all right, but you're not on that same broadcast domain as, say, your laptop or your PC, whatever you're using to host VirtualBox or VMware, all right? And that comes in handy for a lot of things, all right? Because what that's doing is that's taking you off of the actual, it's taking you off of your network, but that's taking you off the production network, because you got to look at your network, your actual network that you're using for everything in your house, your PC, your cell phones, everything else, for your gaming devices, for your smart TVs, and everything else. You got to look at that as the production network, and you don't want to disrupt your production network, meaning you don't want to make some kind of interference. You don't want to cause something to disrupt that connectivity, because things in your house will not be able to connect to the actual internet. So that's why it has that NAT. That's why it has that NAT selection, that NAT interface, because it gives you it takes you off of that actual network and puts you on your own broadcast domain. So when you experiment and lab with things like DHCP, or you just playing around with Linux virtual machines and you're doing all kinds of funky stuff, because there's all kinds of funky stuff you can do with Linux virtual machines and whatnot. I mean, it's almost endless these days. You don't want to say you're doing something like that. You don't want to be actually on your production network. You want to be off on your own broadcast domain. So that way, again, you don't do anything to interrupt your actual network. Okay, so ESXi though doesn't have there's no built-in NAT adapter inside of ESXi. All right, there is nothing, right? Because so ESXi, again, it's like Proxmox. It's made for people who actually know what they're trying to do. It's made for people that are experienced with building these types of environments and creating what they need to create. Because I have in ESXi and Proxmox, you can build virtual switches and ports and do all kinds of cool, funky stuff with that. So what I needed to do I needed to use, and there's a couple other images I could use, but pfSense is a great image. I haven't had much experience with it, and this is why I kind of farted on what I was doing today. What I needed though was I need a virtual router image, because what I need to do is I need to build a virtual switch on ESXi, okay, and then I have a virtual router image that has interface that's connected to both the the port or switch, virtual switch on my main production network, and then it connected also to this other other virtual switch, other port that I was going to use as a NAT port. That way I could bridge off another network. So again, I'll be building NAT inside of ESXi, because what the plan was, if you guys joined me last night, you saw I downloaded the DHCP software onto an Ubuntu server, and I also had a Fedora server up, and that's where I left it, because I knew that's as far as I'm going to be able to go, because again, those were sitting on my production network, right? Those, I booted those right up off of the same network that everything else is sitting on within my whole entire house. And the last thing I need to do is to establish that DHCP server on that Ubuntu server, and things would have started getting funky on me. So again, what I needed to do was get pfSense up, because pfSense is a virtual router image. It's a Linux image, but it acts as a virtual router. All right, it's just a Linux image, but it's already pre-configured to act as a virtual router. And as long as I attach, another interface to it, two interfaces, I'd be able to build that topology that I wanted to build, and have that NAT. I would be able to have that NAT, that network address translation that I needed. So not only would I be able to still connect out to the internet, I would be able to pretty much like host an entire, I'd be able to host another broadcast domain inside of ESXi without interfering with my production broadcast domain. Oh, I didn't drop the stream will be starting soon. So let me drop that actually. That's probably getting annoying to look at. Beep, get out of there. All right. So I guess what I didn't, so I uploaded it up to ESXi, and I was trying to boot it up, and I'm like, what? Why isn't it booting up? Well, my Cookus I didn't extract it. So I didn't have 7-zip. 7-zip's a great, it's a great tool. I didn't have 7-zip, and I guess I did because I didn't go through the documentation and read it all. I was just trying to get it all done real fast. But you need 7-zip to extract pfSense to its, original size, ISO, and that's what I didn't do. So just right now, I extracted it all. I got it now all uploaded, the actual real size ISO uploaded to ESXi. But what I did though earlier, and what we'll do is I'll kind of just like tear everything down, and I'll build it back up with you guys. But what I did earlier though, while I was still in that class, because even though I was stumbling, I was still having, I was still having issues and stumbling over myself. Again, I was just brain farting on everything, I guess, because of everything. Again, today was a really, really great day, guys. Today was awesome. Again, I had, I had a lot of miracles happen for me today, guys. So it was, I guess I was just a little bit overwhelmed with everything. But what I did though, anyways, while I was still during the class, because I still wanted to respect the class that I was in, I still created the virtual switch. I still created the new port group, and then I took those VMs that we created yesterday, and I dumped them onto that new port group, that new V switch that I created, and then I got that Ubuntu image up. I added a static IP address to it. I went through the config file, and I created a broadcast domain with with IP addresses and everything else for the DHCP server and whatnot. And then I added the Fedora image to that network, to that switch, and then booted up the Fedora image. And yes, and the DHCP server worked fine. the Fedora image got the IP address allocated to it perfectly in the correct subnet and everything else that I designed the DHCP server to do, well, to hand out and whatnot. Only problem is though, I couldn't. That was it. That's as far as I can get with the lab because I had no I had no access to the internet because, again, and I'll show you guys once we get there. I pretty much just built a, you know, a contained network, and that was it. That's as far as it can go. There was because again, I didn't want to attach it to my my actual production network, because I didn't want that stinking DHCP server doing anything funky to my network. Because you know, it could, you know what I'm saying, it could start handing out addresses, but I don't. All right. But yeah, that's all. What we'll do today is, again, today's going to be lab day. We'll do some, we're going to go through the book. We'll go through those labs from part 1, from part 2, from part 3. You know, but I also want to show you some stuff in the ESXi too, because I know some of you guys out there are interested in you know, in Linux stuff and stuff like that. And I get that because I am too. You know what I'm saying? Linux is just as big as part as the Cisco stuff that I'm learning for networking, because Linux servers are pretty much what runs the internet now. You know what I'm saying? And I'll argue that everybody, you know, from Google to Amazon, they all use Linux servers. You know what I'm saying? Those are the big dogs. You know, Microsoft, you know, Azure, yes, they use Windows servers, but I guarantee somewhere in the mix they got Linux servers doing all kinds of stuff for them too. So, yeah. But yeah. So that's gonna be the day. So again, we're gonna start off in the ESXi. I want to get that BFSense image booted up, and I want to get NAT configured on it, on that bridge, on that switch, on that other network, and then we're gonna see what it can do. So yeah, well, let's get to it, guys. All right, this out of the way. Let's go to. Let's go to this one. Okay. All right. So we're over in ESXi as we were. Everything was good. All right. So let's do this. Create a new virtual machine. We're gonna call it router. I believe it's an Ubuntu. Let me just look at the documentation. I just want to see how much resources I should actually be given this thing. So 4 gigs, 500. So all right. All right, so we're good. We're good. How much space did it say? 4 gigs. That's good enough. Hooked up to that, and we're also gonna We're going to give it another, so we're going to hook it up to these two. So we're going to give it two network adapters. This right here is that other, and I'll show you that. This was the switch I created, the virtual switch I created today. pfSense is there. Just make sure that's connected. Yep, that's connected. That should be good. So what I did was, is in my networking, I built a new switch. Okay, so in here again, I didn't build any physicals I didn't put any physical adapters on it. All right, I didn't give it a VLAN or nothing like that. All right, I just created a new virtual switch. All right, and then I added the port group, because you got to build a port group too. All right, once you build a port group, then that's when you can add actual VMs to it. So you build the switch, build a virtual switch first, and then you create the port group, and then you can add the actual VMs to it. So that's what I did. So this is the port group, and then this is the actual virtual switch. All right, again, no physical adapters, no VLANs, no nothing. All right. So now let's get pfSense up and running. Yeah. That's all right. There we go. All right. This is beautiful now. So, like I said, I was running into I didn't extract it right. Well, I didn't extract it at all. How's that? So, uh, obviously it wasn't booting up. But now look at that. We're doing big things. We're doing pretty good. So Pia did it. Yep. Accept. Type console driver pfSense defaults to US. Yep. How would you like to partition the disk? Auto. Let's go to auto. Let's keep it simple, guys. So what this is going to do, again, this is going to act as our virtual router. So we should be able to configure it. Installation is now finished. Before exiting the installer, would you like to open a shell into a new system to make the final manual configurations? Reboot. Reboot. All right. So what is it asking us? Starting device manager. Yep. Yep. So we have it's picking up the two network links that we have. Do VLANs need to be set up first? No. Enter the WAN interface name or A for auto detection. I'll just say A. Connect the WAN interface now and make sure the action. If named on the interface are not known, auto detection can be used instead of the auto detection. Please disconnect all interfaces before. Again, if the names on the interface are not known, auto detection can be used instead. To use auto detection, please connect all interfaces before pressing A to begin the process. Connect the WAN interface now, and make sure the link is up, and then press enter. I gotta open this. Connect to the client computer at the same network LAN. This computer may be directly connected to the network cables. Switch. Default and there's also a DHCP server. Oh, okay. Enter the WAN interface name. Oh, so it wants to know which one. The wide area network name. So that's BMX V. Yeah, so that'd be BMX 0. Enter the LAN interface name or a auto detection. Note this enables full firewall and NAT mode. So it'll be, okay, BMX1. Yes. Okay. There we go. All right. Cool. So we got our uh, we got our yep, got some IP addresses. Very, very good. Cool, cool, cool. Cool, cool. All right. So what should happen? Now what should happen? Let me just check on that. Yeah. When I boot up, you know what I'm gonna do? I'm going to do. Let's do this. Let me just boot up this one, the Fedora server. Now remember, so I have the Fedora server in that same NAT group as well. And that it currently doesn't have an IP address or nothing like that. Let's open up a console. Look at that. I believe we already got an IP address. So let me just log in as root. And boom. Beautiful. Beautiful. Beautiful, 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 beautiful. And let me just see if I can ping Google. No. Okay. That might just. Just looking at. Okay, believe there's a web boot. Just so let's do this then. Let me take this Ubuntu desktop. Let's edit it. Boot it up. And then we'll see if we can connect to it via the Ubuntu desktop. Because I can open up a web GUI off of there. It's got an IP address, right? That one's got its own. Let me see if I can ping that one. 192.168.1.100. Yeah. So they two can talk to each other. I cannot seem to connect to the actual router. But again. If the default LAN subnet conflicts with the WAN subnet, the LAN subnet must be changed before connecting to this network. Doing the situation predictably will be unlikely to work until the conflict is resolved. The LAN IP must be changed. To the best things in life are great. So let's do option 2. Available interfaces. Enter the starting and ending address. So let's go with 2. Enter the new IP address. Enter. So with 10.0.0.1. For a WAN, enter the new. For a WAN, enter the new WAN. To the starting. Good. want to revert to the HTTP as the web converter protocol. Cool. Right. Sweet, baby. Look at that. All right. This is working perfect. I'm having fun with this now. All right. Different. That's fine. Yes. All right. Cool. We got it. Cool. Get the IP address. Now, let's see if we can connect. So let's see if we can connect to it. One. All right. And that is admin and pizza. Cool, cool, cool. Primary DNS. Um, Already got the DHCP flyer. I don't know why it's asking all these questions. Oh, did it really reload? Oh, jeez. I hope I didn't break it now. Ooh. Alright, so DHCP is good. I gotta think like a router. That's the thing, like a router. Yeah, see, DNS is not working. It's not doing that. I go on the other interface then. This option should generally be turned on unless this network interface resides in such private. Blocks traffic from IP address that are reserved. Ah, so this might be what's doing it. Traffic reserved IP address. Yeah, signed environment. This should never appear. That should never appear. Internet routing table should not appear. This update frequently can be changed under the. So I gotta get into the NAT settings. That's what I gotta figure out what to do here.
Oh, boy, I gotta think about how I want to set this up. Ugh.
I mean, we got it working, but
Mm.
I'm gonna have to do some more research on how to do this. That's cool. So at least we got that up. That was actually pretty successful. So we got to do some more research on PF Sense, but you know what? We got it up. We got it up. So, on the VMware tools or something? Yeah, if you're joining me, we're just going over. I just wanted to get PF Sense up and running. I might have broke it. Whatever. I'm worried about it. I might have broke it. Did I break it? I might be trying to do some funky stuff to my network. I hope it isn't. It's the only thing that scares me about this thing. Yeah. What's up? Um, all right, all right. Let's get out of that. Let's go to Let's get over to It's not installing the. It's definitely not installing the VMware tools. All right. So either way, though, we have. Um, I just have to figure out how to get the NAT set up on it. Once I figure out how to get NAT set up on that, I'm gonna dive into that, and we'll finally have a way to really start building bigger topologies inside of ESXi now. So I'm kind of stoked about that. I'm super happy. Yeah, whatever, kill it. Okay. All right, let's get Cisco Modern Lab up. Let's do some actual real labbing. Let's do some real labbing. Real labbing. Wait, we sue. Come on. All right, let's start with a new lab. Time, we'll call it. All right, let's grab a switches. And grab a desktop. Grab a couple desktops today. And we'll just play around with we'll play around with a switch today. Keep it pretty keep it simple. Switch. UV 10. 20. These. Two. Two. Interfaces to this thing. That should be enough. Let's get that fired up. So what I'm gonna do is we're just gonna use one switch today, and what I'm going to do is we're gonna break this switch off into 3 VLANs. Obviously, VLAN 10, VLAN 20, VLAN 30. I'm gonna build a DHCP server on this switch. I'm gonna have it allocated some addressings and stuff like that. And then well, first before I trunk it, I will have it so only the VLANs can talk to VLANs. Then we're gonna go through, hopefully this switch we can set up SSH server on Telnet. We're gonna set up the whole full battle rattle just on this one switch. So we're gonna spend some time on one switch. So let that boot up real quick, guys. I'm just gonna go get some more drink and use the bathroom real quick. Give me 1 sec. Take a quick break. We've been at it for a little while now. Give me a couple of minutes. So I'll grab some more drink real quick. And look at that. The switch hasn't even come up yet. So, again, today's lab day, guys. I just wanted to go through. I wanted to just do some stuff on ESXi. Just because I really need to spend. I need to increase my knowledge of how to create better topologies and actual real infrastructure inside of ESXi. So things like pfSense, like you just saw me boot up, are going to be very important for me to learn, spend some time on, and get working properly. That way, then I could start breaking you know, my Linux servers off on there, on that network, you know what I'm saying, and be able to just do things a little bit, and just create more infrastructure. That's really, it's honestly the size of it all. It's funny because I've been spending so much time on Cisco. I need to though spend, you know, I need to take, you know, a little bit of time, spend time on learning that type of stuff too. So, but I mean, it's all gonna come. What we're doing today, guys. Well, let's dive into it. All right. So, let's start off from the very beginning. So, enable. All right, enable. So enable mode again. When you first log in, so this is the sense that we're logging into it via the console. So that's what, when I press on the console, so that's where it's doing. And the first mode it's bringing us is to user mode. All right, so that's going to be the first mode it brings us to. All right, when we enter the enable command, all right, that brings us to enable the enable exec mode. All right, that brings us to the very next stage of pretty much like brings us to the next level of power, of authority on the switch, where we can start doing more powerful commands and whatnot. So yeah, so again, we're gonna start off very again from the beginning. We gotta take the step back. All right. So again, so when we first log in, we're in user mode. All right. When we enter the enable command instead of user mode, that brings us to enable mode or privilege mode. All right. All right. And then in there, that's where we can do some more powerful commands, like we just said. Cool. All right. So again, from here, this is where we can start running the you have commands like reload in here, where you can actually reload you can reload the switch, all right, from there. All right. So let's go into configuration terminal mode. All right. So configuration terminal mode brings us to the next tier, where we can start adding altering the configuration of the switch and start so this is going to bring us to the global configuration mode. Okay, so we're in global configuration mode now, and you can see what things are changing. So again, so when we're in enable mode, we have that little hash, and then when we step into the global configuration mode, we have the config with the hash now. Okay. All right. So let's do one of the first commands. Let's do the host name, and let's change this to switch now. All right. And let's go right into it and set up, I'm going to set up telnet and SSH on this switch. All right, let's give it the IP domain name command, and we're just going to say lab.com. Okay, and then we're going to give it the crypto key generate RSA. All right, say 1024. All right. And there it goes. It just says SSH has been enabled. All right. All right. Let's do this. Let's see if enable IP SSH version 2. Okay. Very good. Now let's move into line VTY 0 to 15. Okay. let's give it the login, local. All right, now let's exit. Now let's do the user. Let's do the username. Let's give our user Cisco privilege 15. Give them all. Secret. It's gonna be Cisco. All right. What I just did is I just made that the username encrypted too as well, so that can't be seen. Now let's do the enable secret now. Cisco as well. Okay. So we got that in there. You know what to do? Know what we didn't do? Line BTY 0 to 15. You know what? For now, let's do import, transport, import. We're gonna say telnet and SSH too. Okay. Just for now, and then if we can actually get into this via SSH, we'll remove telnet. All right. All right. So now we have to start assigning IP addresses to this. Okay. I'm gonna leave you open over here. All right. All right, so from here, let's make a couple of VLANs. So we got VLAN 10 we're gonna make, name VLAN 10, the 10s, we're just gonna say 10s. All right, let's go to VLAN 20 now. And let's give that a name of 20s. All right, VLAN 30. And we're going to name that 30s. So we get the 10s, 20s, and 30s. Okay. Exit. All right. And let's do. Key address 10.0.0. Five, 0. Description. Let's say native VLAN. Now let's move into interface. Interface VLAN 10. Give that an IP address. 10.0.10.0. Shot. Description. VLAN 10s. All right. Base VLAN 20. Yes. 10.0.20.1. 0. Shot. Description. 20s. 30. 30.1.2.5.0 chat description. That's it. Huh. So that's assigned. Now, what's assigned? Let's start assigning some interfaces. So, how do I? Let's do a do show interface. Do show. Good. Let's do this. Interface range gigabit 0-1 MSA switch port access 10. Okay. Then let's do the interface and gigabit range of that one. Gigabit 3. Switch port access 20. I want to do the next one right down from it, so that's interface gigabit 0. Switch port access 20. Shut. Then I can do the 1 to 1 to 2. Okay. All right, so interface range gigabit 1 to 0, 1 to 1. Switch port access 30. Shut. Right, that's done. There. Let's copy this real quick to our configurations. Now I want to do an IP DHCP pool. And we're going to say 10 network 10.0 10.0 2.5.2.5.2.5.0 and that'll be default gateway 10.1. Right? And we don't need that. That's set. Let's exit. IP DHCP pool. I'm going to need 20. Say network 10.0.20, 20.0, 0, and default 10.20.1, who exit, again, IP, DHCP, pool, 30, work, 0.30. I got fat fingers tonight. 2 for 5, 2 for 5, 2 for 5, that's 0. Default is 10.31. IP, exit now, exit. IP, exclude 10.0. 10. So 1 to 10.0.10 to 100. Let's run that again. 20.0 to 10. Again, let's change this to 30 now. Write that configuration. Do show run real quick. We got some DHCP up in this switch. Got a domain name set. This I'm saving this interface, but we have 1 and 2 in VLAN as just switch ports. Yeah. Should be good. Make our connections. Happens. Hopefully we get some IP addresses and we can do some other stuff and see how many things we can do just with one switch. We'll find out here now. Very short second. Now let's see if we can telnet. And that's 10.0. Let's try 10.0.10.1 first. Cisco. Cool, so we can telnet. All right, so let's. And as you can tell, since we set the, so one thing to add, when I set the privilege to 15, instead of it bringing us to user mode first, as you can tell, it actually brings us right to configuration terminal mode. Okay. All right, cool. All right, so that works. So let's exit and then exit. All right. And let me just make sure. Now let's see if we can actually SSH. L. Let's go to 10.1. Yeah. It still does not like SSH. That's a real bummer. That's a real bummer. But I mean, you saw we went through the actual setup on it. But still, we're getting that same, same. How am I gonna say it? Bug, I guess. Cool. We got IP addresses all in the correct ranges. Answers real quick. Beautiful. I just want you to know you're my favorite girl. Now, I shouldn't be able to ping anything. Well, I shouldn't be able to ping, say that. So, see, I can't ping that. Okay. And I should not be able to ping any of the other PCs either. Oh, no, I can. But I can't ping that other one. Well, that other one's not set up on an interface. And I didn't set up trunking at all. See how that works? Pretty crazy. What's that? 102. Let me see then if I can tell it. Ready? Yeah. Ready? Line switches are another thing. And it's probably because, let's do this. All directly connected, right? And that's why it's allowing, but I pretty much just turned it into a router. Yeah, I turned it into a router, and I added multiple. It's like adding multiple interfaces to that router, pretty much. That's what the VLAN's pretty much doing. Even though they're not, because they're now working, now doing layer 3 IP packet forwarding, and not so much relying. Let's look at some of the I wonder if I should get Wireshark up. Let's get Wireshark up. And let's go to the let's capture packets. I want to see what's going on. Close real quick. Let's open it up. So here we go. We're over in Wireshark, guys, and I hope you guys can see that. Yeah. So this would be a better way for us to take a look at these packets. All right. At least this is like the real way to take a look at these packets. You'll be looking at them in Wireshark. So let's take a look at them then in Wireshark. So what do we got? We got some spanning tree. I want to look at these pings, and I want to see how it's doing this. Some source test, yeah. What I'm looking for is I want to see it's adding header field to it. It's not being trumped, not the one. encapsulation type. All right, yeah. So encapsulation type, it's just showing Ethernet. Okay. Not what I'm looking for. I want to see. There is no tags. So there's that number again, 32,768. So that's the default STP. That's the default STP root priority number. Remember that, 32,768. That was the one we actually got. We got it right yesterday, but remember, so that's always the default STP root number, 32,768. And remember, the default time's always 2 seconds, and it's all the max age is always 10 times the hello timer. So since it's set at 2, 10 times 2, 20, obviously. So there you go. All right, so that's just STP. We're not doing any STP stuff right now. There's some art messages. It's funny because it's sending art messages. They should already know where they're gonna send it anyways, I guess, right? Oh, okay. 10.101 is sending it out of the MAC address, target IP. And I'm guessing it's doing that because it's the actual 10 dot. It's looking for 10.1, which is just a VLAN. That's probably why it's coming up with this address right here. I like looking at these. You guys might think this is boring, but I think it's awesome looking at these packets. Source MAC. Source MAC's probably just actual. So there's the reply. And it's pretty much saying 10.0.1 is at probably just stating that it's at the actual. Let's look at this span tree. So 1832. Let me write that down. Let's just do 18.3b delta 6. $18.80. Oh, it's even. Hmm. $18.83. More STP. Here's some CDP messages. So remember, CDP is Cisco Discovery Protocol. Oh, that's DDP. Dynamic trunk protocol. The rest are just more spanning tree. STP messages. My ICMP. Oh, here's CDP. Here's CDP right here. CDP, I'll show you. CDP, this is why you want to disable CDP on edge devices, because look, it even gives us our domain name right there. So the device ID switch.lab.com. So that was the domain name that we set for it. Gives it your whole entire your all the information of it, platform, addresses. It even gives us the port ID, where it came from, some of the capabilities. Gives us the VLAN and stuff like that. Obviously, because it came off of the interface that we captured that on these frames off. All right, so that's that. So let's add some more stuff now. Let's come over here. Let's do this first. Oh, I broke it. Ooh, this might break. Oh, that came back. Okay. Baby, come back. Let's set up. Let's set up. Let's set up a DHCP server also for the VLAN. Oh, okay. Yeah, so I only have those 3 VLANs. So let's do IP DHCP pool. I'm gonna call you 10.0.1 1.0. One P exclude 1.0 to show run. Now let us interface gigabit 0.0. This is going to be a switch port. I'm going to say switch port trunk on this one. Trunk encapsulation. Double Q. Port. Mode. Name of desirable. also, what I also want to do is let's make a port channel. So we got to go into, let's add that other interface to it too. So 1-3. Whatever, it doesn't have to be the same. So let's go into interface, gigabit 1-3, switch port, trunk, encapsulation, Q, switch port, dynamic, desirable. And then we have to add channel group, channel group 1, channel group 1. What was it? Mode. Desirable. Go back to do the no shot on this one though. Let's go into interface. Gigabit 0-0. And that is now going to do channel group 1 mode desirable. All right. Shot. We should have a port group that's trunking over to the next switch now. And we should be making a trunk and also make a port group too. We'll see. So group 2 show within that. Do show interface from. Let us look at. We gotta look at some of our show commands. These port groups. Let's go back. Do show ether. Our port group is up. It's using PADGE, which is Port Aggregate Protocol. That is the Cisco protocol. Remember? Okay. Let's look at some information. desirable port channel 1. Yep, port channel 1, cool. Its protocol is patch port aggregate protocol Cisco. Gigabit 0-2. So we do have we made a trunk. All right, so it autoed. All right, on the two interfaces that we made for VLAN 1. Very good. And let's look at do show Ethernet channel port Ethernet channel. Maybe. So we got detail. Nothing. So we got one summary. There. Do show spanning tree. Yeah, I feel as though our port group did not successfully take. Let's do another do show Ethernet channel. Let's look at port channel. It's saying that it's up. I think. port state up. Okay. It's stating that it's up. Do a sum. Got what it says. Go to this switch now. And let us, what are the two interfaces that we put that in? So that was in, so we can do an interface range, gigabit 0-0 to 1. We can say channel group 1 mode auto, right? Let's give it a shot. And that should bring up our port channel now, right? Oh, cool, it did, right? It did, we did it. Okay, so we dynamically, all right, so now let's run summary. Cool. So now it should be up now. So when we run spanning tree now, do show spanning tree. All right, cool. Now we're seeing the port channel. So our port channel is up. Cool, cool. That is cool, guys. All right. All right, so our port channel is up and running. Nice. Nice. And let's do a do show spanning tree. Oh, I mean, so let's exit. Let's do a do right. I need to write this. Nice. All right, so yeah, so our port group's up and it is working. Cool. Cool. And remember, so it's 32,678, but since this is residing on VLAN 1, it's just picking up that 1 and it's adding it to that number, so that's why it's showing the 69 instead of the 68. This is cool. This is cool. I'm having fun. Yep, 69. And then since this is VLAN 10, 78. All right, this other one would be 88. The other one would be 98. See? All right. Now let's take a look at some load balancing. Some load balancing. All right. And what we're gonna do. How many interfaces do I have? 2 interfaces on this? Yeah, I've got 2 interfaces on this. So what I can do is use what I'm going to do is I'm just going to create a VLAN 10 and a VLAN 20. I'm not going to assign any IP addresses to anything on this switch, and I want to see if I will be dynamically allocated addresses and all that kind of happy stuff too. Put you up here because you're going to be VLAN 10 and you're going to be VLAN 20. I just ran out of interfaces on this one because we made that up. We made that I should have just added more. That's fine. Whatever. And switch. Let's change your name to secondary. Now I'm gonna make 2 VLANs, so I'm just gonna do VLAN 10. Okay, and then I'm just gonna name the same thing. 10s. VLAN. Name. Exit. And the 2 interfaces. So what? So you're gonna be gigabit 0-2. So VLAN 10 is going to be out as gigabit 0-2. Gigabit 10, yeah. So interface gigabit 0-2. Switch port, access 10. Shut. Description. That's it. We can just move right into the other. So that's 0-3, right? Interface, gigabit 0-3. Switch port, access, 20. No. Description. That's it. 10-3. Yep. Ooh, you know what I want to see? Do show interface trunk. I want to see if it shows the port group. Do that. It does. All right. All right, we're good. We should be good. All right, let's see if we got some IP addresses. I'm really curious if we did. Yes, we did. We did it. We did it. All right, let me see if I can should be able to ping that other 10.0.10.3. Sweet deal. Man, it's been a fun lab day. This has been a good lab day, everybody. Ooh, juice. Let me run to the John again. Hold on, guys. All right, so let's do some load balancing. Man, what an awesome lab this is. What an awesome lab. All right. All right. So it's load balancing off of source destination IP. Internet channel load balancing address used per protocol, non-IP sources. So it's using source destination IP, which is cool. let's do this then. Test Ethernet channel. Trying to, it's like I'm missing a command here. Problem is there's two Ethernet. No IP addresses for. What my is definitely missing something. I'm missing the Ethernet channel command. Man, I hate when these things are just not. Want to test load balancing. That's what I want to do. But the Ethernet channel command is missing. It's always just something. This thing. Let's just go. Let's do show Ethernet. Show. What's this? So it's doing source. It's doing source and destination IP. So let us I mean it's doing the right thing. It will more efficiently load balancing as it has it set up. And because we're using this switch primarily on the layer 3, on the network layer, doing a lot of IP, because we got pretty much main switch is acting like a layer 3 switch right now, which it is a layer 3 switch, and then the secondary switch over here. Now we can look at this one though, and let's do show Ethernet channel load balancing on this one, and that's set up for destination IP. And that's probably because it may be picking up that configuration from how we have it set up on the actual channel group. Because remember, we have the channel group being dynamically created, because we're using the port attribute protocol desirable command on the main switch, which then dynamically created the port channel once we gave the secondary switch the auto command. And we also have the trunk being dynamically created too, by giving also the main switch on the port group 1 the dynamic desirable command on the trunk as well. That's also doing that. So, I mean, we covered a lot. And then we can still telnet 10.0.10.1. I mean, yeah, so telnet's working, but again, SSH is still giving us, it's still due to whatever Cisco's Monolab issue is with SSH. It hates SSH for some reason. I'm just trying to go through what else we haven't covered just in these last chapters. I mean, we even did some stuff with, just because I didn't want to break out a router, and I just wanted to do some funky stuff with a switch today. I mean, I could add another, but I don't have any more ports, do I? All my interfaces, I believe, are now all that right. Yeah. What's left? VLANs, we covered VLANs. We really covered, I mean, kicked the butt out of VLANs. Kicked the butt out of trunks. We just went over Ethernet channels. But I'm just trying to come up with more stuff, guys, to go over. Because even though we've gone through a lot of these chapters, I mean, a lot of this is just fundamental. A lot of in the beginning of these chapters was just fundamental knowledge. Yeah. All right. I mean, we did pretty good today. Again, so let me see. So Monday we'll pick up on part 4. All right. So Monday we're gonna be picking up on part 4, and remember, we're gonna be getting into subnetting, and subnetting will give us a headache. Okay. So part 4 is chapter 11, chapter 12, chapter 13, chapter 14. Chapter 11, perspectives of IPv4 subnetting. Chapter 12, analyzing classful IPv4 networks. Chapter 13, analyzing subnet mask. Chapter 14, analyzing exiting subnets. Okay. Yeah, so pretty much what it states is the book is going to take a hard transition away from layer 2, all right, and we're going to be getting into the next level, okay, which is the network, which is IP packets subnetting. All right, subnetting is where a lot of us, especially myself, this can be a hard part to wrap our heads around. Just because subnetting it has to be something you've got to think about and plan out, and it can be something that can get confusing if we don't get the fundamental blocks in our brains now. It's going to get harder for us to continue to go forward on our journey here together. So again, that's why I want to pick up Monday with some fresh brains. We did really good. This, again, I know I messed around on ESXi. I just wanted to just showcase some of that stuff that we'll be getting into as our journey continues together. Because we have got to take the knowledge that we're getting from the CCNA exam. We got to take that knowledge that we're getting from there and all this Cisco knowledge, and we got to be able to transfer that onto many other things, and that includes cloud engineering, cloud network engineering. That includes virtual VMs. That includes software like ESXi, Proxmox, VirtualBox. There's so much else. DHCP servers, DNS servers, Linux. We have to take all what we're doing, and we got to make a complete circle out of our knowledge, guys. So that's, again, that's why I kind of want to just showcase where our journey is going to be going. Almost at the same time. Obviously, this is primary. CCNA studies will be primary, all right, till we all become CCNA certified, all right. And once we become CCNA certified, like I said, we'll be getting into DevNet stuff, DevNet. All right. DevNet is we gotta get our Bash skills up. We gotta get our Python skills up. Okay. APIs. We got to get our heads around APIs. APIs. I've got to really wrap my brain around API knowledge. Okay. But VMs, virtualization. All right. These are the things that DevNet and that we're going to be taking on when we take on the DevNet exam. Docker, all right, Ansible, all right, Kubernetes, all right. These are some other things that, again, Cisco is going to be the foundation of where we're going to be building all of this off of. Okay, but it branches off into many other things. But doing this is primary. This is fundamental. We have to learn this, okay? It's all important, guys. All right. I want to thank you all again for giving me you guys' time. You guys' time is valuable, and I appreciate every second, every nanosecond you guys give me of your time is extremely valuable, and I appreciate it 100%. I love every single one of you guys. Thank you so much for joining me today. You guys will probably see me pop up on Twitch. You guys will see me probably pop up on Twitch over the weekend. I usually do some gaming. If I come across a lab that I want to do, you guys will probably see me pop up on there and doing some lab and stuff. But yeah, I try to spend time with my kids and try to have fun with them over the weekend. So that involves gaming and stuff like that. Plus, I'm a video game nerd myself, and I love playing video games, guys. I'm always trying to find a fun game to really de-stress my brain off of. But again, this has been an awesome day. We have some really good news. I can't wait to keep you guys updated on how things will start coming together and stuff like that. This channel is just going to continue to, I'm still going to continue to put 110% into the focus of building this channel, because this channel, again, this is an extension of my studies. Okay, this is an extension of my journey, and I just, I'm hoping that you guys come along with me, and if you guys can pick something up along the way, man, that's priceless to me. That would be priceless, because that is what happened with me. There was, a couple of gentlemen in particular that I stumbled upon their videos, and then, they're on their journey in life, and I picked up on what they were doing, and I learned something from them, and, my life has dynamically changed ever since then. So if I can have that effect on at least one person out there in the world, that is a priceless thing, guys. That is extremely priceless, and I would be so happy to hear back from somebody. Even if I could spark an interest in something like that for you guys. So, with all the love in the world, guys, I hope you guys have a great, safe weekend, and we can join up again back here on Monday, 5 o'clock, all right, p.m. Eastern Standard Time, and we'll go from there. All right, guys. Mwah! You guys have a lovely night and have a great weekend. All right, everybody.